In this video, we'll learn about the specular section of the standard surface shader. Let's use a dark color with the RGB values of 50 to see the specular contribution a bit better. Normally, specular reflections are more visible on darker surfaces. Specular is direct and indirect reflections that can be sharp or rough. Specular weight here controls the amount of reflection you want on the surface. Decreasing this value makes the specular reflections less visible, and increasing it would have the opposite effect. Basically, it influences the brightness of the specular highlights. In more modern PBR workflows and in trying to make the shader as physically accurate as possible, we tend to keep the specular weight at 1 for almost every single shader, for plastic, wood, concrete, ceramic, and everything in between. You will leave the specular weight at 1 and use specular roughness and the IR values to customize your specular reflections. Keep that in your mind. There is a lesson in this section called How to Shaders where I show you this simplified approach to realistic shader creation. Do check that out to see how that works. For now, let's move on. Specular color here controls the color of the specular reflections, and you should keep this color at white or grayscale values for non-metal surfaces. In the previous lesson, we learned how when the metalness value is set to 1, this color determines the etch tint color of the metal. We can use a texture to control the specular weight or color. For example, let's load this texture called BW21. And connect it to the specular weight. This is a black and white texture, and you see where the map is white or 1, we get a reflective surface, and where the map is black, we get only the base color without specular reflections. We can set the map as the beauty shader and see it on the geometry. For most of my shaders, I tend to leave the specular weight and color to 1 and white respectively, as it is both easier and more accurate to add variations to the specular reflections using only the roughness and maybe the IR values. We talk about this more in that how-to lesson. For now, let's disconnect the image and delete it. Set the specular weight to 1 and color to white. Then we have roughness, which controls how sharp or rough the specular reflections will be. As I decrease this value, we are going to get sharp mirror-like reflections, and as I increase it, we're going to get rougher and blurrier reflections. This is the single most important parameter in the standard surface shader, in my opinion, hands down. The key to realism is specular roughness and how good you can add variations to it. Let's load this texture called BW38. I'm going to set it as the beauty shader. This texture is mostly white, and the roughness value, if you remember, goes from 0 or black, which gives you sharp reflections, to 1 or white, which gives you rough reflections. This texture is mostly white with some dark patches. So if we connect this image to specular roughness, we get a very rough specular reflections with some sharp patches here and there. Let's connect this texture to the specular roughness and set the standard surface shader as the beauty shader. And this is what we are gonna get. Very rough specular reflections with some sharper patches here and there. You can modify these texture values in terms of darkness and brightness to control the roughness. So let's make this image to go through a ramp float node before connecting it to the specular roughness. Add a ramp float node, and this node basically gives you a curve or a ramp to manipulate the incoming data. So connect the texture to the ramp float node. And for now, let's set the ramp float node as the beauty shader. The left point controls the dark values of the texture. So if I increase the Y value, those dark patches become brighter and brighter. Set it to 0 for now. And the right point controls the brightness values of the texture. So if I make its Y value lower and lower, the brighter parts of the texture will become darker and darker. In this case, I want to completely invert the image. And now, because the texture is much darker with some white patches, if we take a look at our standard surface shader again, we should get much sharper reflections with some rough patches. And that is the result we are getting. Very cool. So if there is one parameter that you need to spend most of your time on it, it should be specular roughness. Try to make sure it is as perfect as possible because adding those variations to specular roughness makes your material more real to the human eyes. For now, let's use a simple value of around 0.1 for the roughness so we can discuss the rest of the parameters here. The next parameter is IOR or index of refraction. For shaders that are not transmissive or refractive like glass or water, this parameter controls Fresnel reflectivity. But for transmissive surfaces, it will control both the Fresnel reflectivity and also index of refraction. Fresnel effect or law states that the strength of reflections on a surface is dependent on the viewing angle. The reflection increases as the viewer's angle of incidence. That means in real world, the faces that are parallel to the camera or to the eyes are less reflective, and as the faces become more perpendicular to the viewing direction, they become more and more reflective. And at the incidence angle to the viewing direction, almost every single surface will become 100% reflective. IOR value controls this effect. The lower the value, the stronger this effect is, and vice versa. If I set the IOR to something low like 1.1, now we get a very strong Fresnel reflectivity because the parallel faces are almost non-reflective, and as the faces becoming more perpendicular, they also become more and more reflective. Now if I gradually with 1 point increments increase the IR value, 1.2, 1.3, 1.4, 1.5, 1.6, we are making the Fresnel effect less effective, which means the reflection strength will be more even on the parallel and perpendicular faces to the viewing direction. You don't have to guess this value. There are some IR presets for water, glass, plastic, and so on. And you can obviously search the internet for exact IR values for different surfaces. For most daily materials like plastic, wood, concrete, and so on, you can use IR values between 1.5 to 1.65 or 1.7 safely. For water, it's something like 1.33. For glass is 1.52. And if we keep increasing the IR value to something like 5, 10, 20, 30, or 50, we start to see a metal-like surface. That is because the Fresnel effect at these higher values will become so weak or non-existent that the reflection amount on the parallel faces will even out the reflection strength on the perpendicular faces, and that is another way to create metal shaders. In this case, you can use the specular color alone to determine the type of the metal. For example, I can use a pale yellow to create gold here. But stick with the metalness approach to create metals. For now, set the base color to white and metalness to 1 and specular roughness to 0.2. Anisotropy controls how directional the specular highlights should be. By default, it is set to 0, which means isotropic, and the specular reflections are not directional. As I increase this value, you can see how the highlights are stretching and becoming more directional. Anisotropy rotation changes the orientation of the anisotropic reflections, and as I change this value, I'm basically rotating my stretched out highlights. Obviously, you can assign textures to both anisotropy and anisotropy rotation and create some cool effects. In this case, let's load this radial anisotropy texture. Set it as the beauty shader to see how it sits on our geometry. I'm going to increase its scale to about 2 and now connect it to the anisotropy rotation and set the standard shader as the beauty shader. And now we get these complex specular reflections. You don't have to necessarily use the anisotropy and anisotropy rotation in these obvious ways. In combination with specular roughness, these two can be used to achieve subtle but really realistic surface variations, which is a bit more beyond the introductory purposes of this course. Do check out Mograph Plus's YouTube channel. I'll be trying to talk about that in a separate video there. So that's about the specular section of the standard surface shader. See you in the next one.